So DLCO Unit 2 short answer questions. Question number 1, JK flip-flop was mentioned. Write the truth table for the JK flip-flop and the circuit diagram. This is the circuit diagram for JK flip-flop. This is the block diagram of SR flip-flop. For the SR, if you add two AND gates, it will become JK. One is J input, another input is K. Outputs are Qn and Qn bar. Outputs are complement to each other. So JK, Qn is the prime state, Qn plus 1 is the next state. Two inputs means four combinations 0 0 0 1 1 0 1 1. For 0 0, if prime state is 0, what is the output? 0. If 0 0 case, same. For example, prime state is 1, then output is 1. That means whatever it may be the prime state, we are getting same state as the output. That is no change state. No change, nothing but J is 0, K is 0, prime state is 0. If it is 0, Qn bar is 1. So here this is 0, this is 1, 1 is connecting to this one. J I am giving 0, 0 1, 0 into 1 0. Input is S is 0. Similarly here 0 into something 0. S is 0, R is 0, that is no change state. Output is 0. So similarly we will get 0, and when 1 we will get 1. Prime state is 1, we will get 1. That is no change state. Similarly for 0 1 we will get output is 0. If prime state is 0, output is 0. Prime state is 1, output is 0. If you substitute here, you will get 0. Similarly 1 0, prime state 0 and 1, output is 1. That is set state. This is reset state. Similarly 1 1, prime state 0, next state is 1, and 1 1, prime state is 1, next state is 0. This is toggle state. Toggle means shifting, changing from 0 to 1 and 1 to 0. This is toggle state. Here the same continuation I want to explain in the fourth question. The same question is asking as race around condition. When J is equal to 1, K is equal to 1. J is equal to 1, K is equal to 1. Output is toggle state. What is meant by race around condition is when J is 1, K is 1. What about the output? See, here the clock is, I am taking one clock pulse. For example, the time period is 20 nanoseconds and J is equal to 1, K is equal to 1. Last state, so the prime state for example is 0. According to truth table, when J is 1, K is 1, prime state is 0, next state should be 1. Next state should be 1. This is the actual output. Actual output. Within the clock pulse. Within the 20 nanoseconds, J is 1, K is 1, prime state is 0, next state will be 1. Next state will be 1. But in this condition, what happens means it will come 1, but it will not maintain 1 up to the entire clock pulse, up to 20 nanoseconds. It will come 1. When J is 1, K is 1, output goes to 1, but after some time, delta t times, for example 5 nanoseconds, it will goes to 0, delta t time. Again after 5 nanoseconds it goes to 1, and so on. Like that multiple times it undergoes ones and zeros. When J is 1, K is 1, within the clock pulse, the output undergoes multiple times on and off, 0 and 1. This is called race around condition. This can be overcome by master slave JK flip-flop. Master slave JK flip-flop, that is explained in the long question, 7th question. Similarly, second answer is second and 10th. Short answer second and long answer 10, both are similar questions. Difference between combination and sequential. Output depends on the combination of inputs, that is combinational. Output depends on the combination of inputs. Output depends on combination of inputs and the previous output, that is memory. Output depends on the combination of inputs and previous output that is stored in the memory. This is sequential logic circuit. Without memory, if you are taking output depends on the combination of inputs, that is combinational. That is the main difference. Then similarly, some other questions, some other points you can write. Here in combinational, no memory required. In sequential, we need memory. In combinational, no feedback is there. In sequential, we have feedback, and so on. Similarly, third short answer is serial in, serial out, serial in, parallel out, shift register diagrams. This is a 4-bit serial in, serial shift register. Serial data I am giving. I am constructing the D flip-flop, D1, D2, D3, D4. Clock is connected, synchronous clock. This is synchronous clock connecting to all flip-flops. So this is serial data we are giving and serial output we are taking. This is serial in, serial out, shift register block diagram. Similarly, serial in parallel means same input, output we are collecting at a time. This is the output QA or Q1, Q2 and Q3 and Q4. If all outputs we are taking at a time, that is parallel data. Parallel data. Serial in serial out is input giving serially. After 4 clock pulses, you will take output serially. That is serial in serial out. Similarly, same circuit, if you are giving input one by one, and after getting 4 outputs, if you are taking 4 outputs at a time, that is parallel output. Serial in parallel output. Similarly, binary counter. Binary counter. Fifth question. Here we are giving one input signal. I am constructing a 2-bit binary counter. Here we have a synchronous counter and asynchronous counter. Synchronous means clock is connecting to simultaneously all flip-flops. This is clock signal connecting to 2 flip-flops at a time. That is synchronous counter. Asynchronous means first flip-flop output acting as the clock and so on. That is asynchronous. This is synchronous counter, and these T's we are connecting to 1. This is binary counter, binary 2-bit counter. 2 flip-flops we have 2-bit counter. These are short answers in the part A of second unit. These will cover in the long answer questions also.